The Sun, our life-giving star, is a massive nuclear fusion reactor, burning with unimaginable energy at its core. Every second it fuses millions of tons of hydrogen into helium, releasing a staggering amount of power. This process blasts out energy and light, flooding our solar system with warmth and brilliance. But it's not just warmth and sunshine that reach us. The Sun is also a source of powerful, invisible forces that shape our world in ways we often overlook. The Sun constantly hurls a stream of charged particles, called the solar wind, across the solar system, creating a vast, ever-changing space weather system. This solar wind travels at over 1,000,000 miles per hour, racing outward in all directions, sometimes intensifying during solar storms. It carries with it protons, electrons, and a tangled magnetic field, all swirling through the vastness of space. Imagine millions of tiny, electrically charged cannonballs fired at Earth every single second, bombarding our planet relentlessly. Without protection, this intense radiation could strip away our atmosphere, erode our planet's surface, and threaten every form of life as we know it. It's a cosmic paradox. The Sun gives life, but its wind could just as easily take it away, leaving a barren, lifeless world behind. Luckily, Earth has a secret weapon, an invisible shield, our magnetic field, that stands guard and keeps us safe from these cosmic threats. This natural defense is one of the main reasons our planet is so full of life, allowing ecosystems to flourish and our atmosphere to remain intact. Understanding how this shield works is a thrilling part of space science, revealing the delicate balance that makes Earth unique in the cosmos. It's a story of cosmic forces, dazzling lights like the auroras, and planetary ingenuity that has allowed life to thrive against the odds. The Sun's wild side is always with us, but so is our planet's resilience and ability to adapt to the universe's challenges. Ready to see how Earth stands up to the solar wind? Let's get into it and explore the science behind our planet's incredible shield. Earth's shield is called the Magnetosphere, a vast and powerful force field that surrounds our planet. It's generated deep within the planet by our spinning molten iron core, which acts as the engine for this invisible shield. This core acts like a giant dynamo, constantly churning and creating a magnetic field that wraps around the entire globe, protecting everything on the surface. You can't see it with your eyes, but the magnetosphere stretches tens of thousands of miles into space, a giant, invisible bubble that shields us from harm. The magnetosphere deflects most of the solar wind, a stream of charged particles from the Sun, protecting our atmosphere and water from being blown away into space. Think of it as a cosmic goalkeeper, always on duty, guiding and blocking dangerous particles and radiation around us. If the solar wind is a rushing river, the magnetosphere is a massive rock that diverts the flow, creating a calm, protected zone where life can thrive and evolve. Our magnetic field isn't a perfect sphere, it's squashed on the sunward side by the relentless solar wind and stretched into a long tail on the night side, shaped by the forces of space. This tail, called the magnetotail, can reach far beyond the moon, extending hundreds of thousands of miles into the darkness of space. The magnetosphere is always shifting and flexing, battling the solar wind in real time and sometimes unleashing spectacular auroras when particles slip through. Its dynamic nature is key to Earth's habitability, making our world a safe haven for life in a harsh solar system. Understanding this ever-changing barrier helps us predict space weather, protect our technology, and safeguard our way of life. It's planetary science in action, unlocking the secrets of our planet's invisible guardian. When the solar wind slams into our magnetosphere, it creates a boundary called the bow shock, like a wave at the front of a speeding boat. Most particles are deflected, but some get trapped, bouncing between the poles in the Van Allen radiation belts. Sometimes a strong solar gust injects energy into the magnetotail, snapping magnetic field lines back toward Earth. This accelerates particles toward the poles where they collide with our atmosphere and create the aurora. Oxygen glows green and red, nitrogen blue and purple, a cosmic neon sign. The aurora is a visible reminder of the Sun's power and our planet's defense. It's a light show powered by a star. Our magnetic shield isn't flawless. It has weak spots at the poles called polar cusps. Here, magnetic field lines funnel straight into the atmosphere, creating two skylights where solar wind particles can stream directly in. The cusps are our only direct window into the solar wind, making them a scientific goldmine. These regions are hotspots for auroras and energy transfer from the Sun. Studying the cusps is like putting a microphone next to a speaker. You hear everything. But these entry points are also vulnerabilities. Particles entering here can disrupt satellites and future space missions. Understanding the cusps isn't just curiosity, it's crucial for protecting our technology. The polar cusps are where space weather gets personal. They're both a laboratory and a challenge for scientists. What happens here affects us all. That's why we study them. The clash between solar wind and magnetosphere is called space weather. Space weather storms, triggered by solar flares or coronal mass ejections, can disrupt life on Earth. Satellites, which handle GPS, communications, and weather, are especially vulnerable, especially near the polar cusps. Solar storms can damage electronics, shorten satellite lifespans, or knock them out entirely. On the ground, strong storms can induce currents in power grids, causing blackouts. Radio communications and navigation systems can be disrupted. For astronauts, space weather means increased radiation risk, especially outside the magnetosphere. As we plan missions to the Moon and Mars, understanding and forecasting space weather becomes vital. Our shield protects us, but our technology and explorers need extra help. Space weather isn't just science, it's a real-world challenge. That's why we need to keep watch. To better predict space weather, especially in the polar cusps where Earth's magnetic field is most vulnerable, NASA launched the TRACERS mission, a groundbreaking step in space science. TRACERS, Tandem Reconnection and Cusp Electrodynamics Reconnaissance Satellites, uses two identical satellites flying in precise formation through the northern cusp, a region where solar particles pour into our atmosphere. Why two? Like two boats gliding side by side on a river, these satellites help scientists figure out if changes in space are happening over time, or if they're happening across different locations in space at the same moment. Each satellite is packed with sensitive instruments that measure magnetic and electric fields, as well as all the energetic particles streaming in from the sun, data that's crucial for understanding space weather. By comparing their data, scientists can map the cusp in 3 dimensions, revealing how energy and particles flow into our atmosphere and interact with Earth's magnetic shield. This gives us our best look yet at the drivers of auroras, the beautiful northern lights, and the hazardous space weather that can disrupt our technology. Using multiple small satellites, called a constellation, offers a more complete and dynamic picture of space than relying on just one big satellite ever could. With tracers, scientists can update and improve our space weather models and forecasts, making them more accurate and timely. Better forecasts mean we can take action to protect satellites, power grids, astronauts, and even airline passengers from the effects of space weather. It's science in action. Teams working around the clock, using cutting-edge technology to safeguard our future and keep our modern world running smoothly. Missions like TRACERS are transforming how we study space, giving us new tools and insights to understand our place in the universe. The more we know about space, the safer and more prepared we are here on Earth, protecting our families, our technology, and our way of life. Our eyes in the sky are always watching, helping us unlock the secrets of space and keep our planet safe. Every science mission is powered by people, and TRACERS has a special story. Its original principal investigator, Dr. Craig Kletzing, dedicated his life to studying space's invisible forces. Dr. Kletzing was also a musician, building and playing electric guitars. He passed away before TRACERS launched, but his team honored him in a unique way. They attached 2 of his custom guitar picks to each satellite, a symbol of his passion and creativity. As TRACERS orbits Earth, those picks carry a piece of their creator through the auroras he loved to study. Science isn't just data and machines, it's a human adventure, full of wonder and inspiration. The guitar picks remind us that we bring our humanity to the stars. Dr. Kletzing's legacy lives on in every discovery TRACERS makes. Science is about teamwork, honoring those who inspire us, and reaching for the unknown. The data from TRACERS will protect our future. The guitar picks remind us of the heart behind the mission. Even in space, we carry our stories with us.